Hi, good day. My name is Charlene Alea Rivera from DSC 3I. I am discussing one of the topics of dynamic of rigid bodies, which is the instantaneous center of zero velocity. So let's start by solving an example. Example number 1. The wheel rolls to the right without slipping, with its center having a velocity v sub o 3 meters per second. Locate the instantaneous center of zero velocity and use it to find the velocity of point A for the position indicated. So below the problem, we can see our illustration or the figure of the wheel. So we have a dimension which is 200 millimeters, and we have r is equals to 300 millimeters, and we have point A, point O, which is the origin. We also have velocity sub O, 3 meters going to the right. So what else? We have here in the right corner, we have the FBD of the wheel, which is the vector velocity A, which is perpendicular to the point A. So same measurement, 0.200. So if we convert the 200 millimeters to in meters, we can get 0.200 meters, 0.300 meters, and 120 degrees. So as you can see, we have 30 degrees, and in the FBD, it's already 120 degrees. So we will tackle about it later. So moving on. So let us personally solve the problem. So basically, the point on the rim has no velocity, no direction. If the contact in the ground, assuming that the wheel is not slipping. So therefore, the angular velocity of the wheel turns into angular is equals to v sub r, which is angular is equals to v sub o line OC. So this is the given velocity, and this one is the line O to C, which you can see in the figure in the previous. So we have velocity given, which is equals to 3, and we have line OC, which is converted to meters already, so 0.300. So 3 divide 0.300, we have here 3 divide 0.300, we have 10 rods. So that would be 10 rad per second. So using the distance formula, we can now get AC, line AC is equals to 0.302 plus 0.202 minus 2, 0.300, 0.200 cosine 120 degrees. Many of us are thinking why it's 120 degrees. So it is basically we have the existing degree, which is 30 degrees. So if we remember the unit circle, so we have here 30 degrees, and then why is it 120 degrees? So it is simply because we have 45 degrees here and another 45 degrees. So 45 by 45, 90 plus 30, we have 120 degrees. So this is basically just using the distance formula, if we can remember. So further solving this, so square root of 0.300 squared plus 0.200 squared minus 2 quantity 0.300 multiplied by 0.200 cosine 120, we can now get value of 0.436 meters. So that is our line AC, guys. So therefore we can now therefore we can now get the velocity of A. So let's start. So V is equals to R angular. So we're gonna get this. So it is simply a multiplying or cross multiplication of this formula. So after this, we can now get to this. Okay. So other than that, so V velocity ng A ay line AC line AC, and multiplying it by the angular. So this is the angular value, this is the line AC value, simply multiplying those. So 0.436 and then multiply by 10, we can now get 0.436 multiplied by 10. We have now 4.36. 4.36 meter per second. So that would be our final answer. So 4.36 meter per second. So remember that VA is perpendicular. So that's it for today, and thank you. I hope you learned something. If you have any questions, just comment down below. Thank you.